Moira. This is maintenance.
Okay, now we would like to begin with the pin plate. So at first we have to turn off the main supply. Turn off the main supply, and also the fan must be removed. So now we have to fix in the pin plate. And you have to screw it. Plug the heater. You plug the heater.
Ni lagi ni.
Oh ni.
Boleh.
Okay. Okay dah. Turn on the switch. For the heater is T2. For the fan is T1. And for the probe, T3.
So now we turn on the power and we turn it to 15 watts. And then we wait for the temperature to stabilize. And this for 10 minutes. Okay. Then yeah. And then we turn on the fan speed.
No bro, no.
No?
No airflow.
No airflow at all.
No airflow.
Okay. Got it. So after the temperature is stable, we have to turn it back to 0. And then we check the data for 0, 5, 10 until 50. So after we're done with this, we have to turn off the power. And we have to change the pin to pin and flat surface. We repeat after test.
Hi, my name is PATERUS. Today I'm going to present the result of our laboratory 3, that is free convection. This is the result for fixed power with the power of 15 watts. So we have 3 surfaces. The first one is flat plate, fin, and pin. So we can see here that the surface for T2 and T1, and the temperature is 66, 52.2, 53.6, and for duct inlet for T1 is 25, 30, and 26. And then we calculated the difference between T2 and T1. That would be 41 for flat plate, pin for 25.2, and fin is 17.6. The next table is the power and temperature for pin type. For this table, we measured the temperature for T2 and T1 for power from 0 until 50 watts. So, and then we found out the differences between TS, that is T2, and TA in, that is 41. And then we put all of it in this table. And then the next one is power and temperature for pin type. So in this table, we do the same as the pin type. We find the temperature for T2 and T1 with the power given from 0 until 50. And then we calculated the differences between TS and T1. T in. That's all for me. Thank you.
A very good day. My name is Jeremiah Darshan and my ID number is B0920103770, and today I'm going to present on Lab 3 discussion. So the question is, create a suitable chart for your results. Compare your results for each surface. Which surface created the highest temperature difference in free convection? What can you say about the surface? So this is the graph for the free convection on different surfaces, and there are 3 different bars, which is flat plate, pin and fin type. In the graph we can see that the flat plate surface has the highest temperature difference compared to fin type and pin type surface in this experiment. Unlike the fin type and pin type surface, the heat can be distributed to the surface and promoted the turbulence within the flow channel and enhance the convection of the heat transfer, while the flat surface hardly perform heat transfer and convection of the surface, thus created a high temperature on the surface. So give an example on application of the surface you mentioned in question 1 in any system that you know. So the example of application is heat sink in the central processing unit, or also known as CPU. That is all from my presentation. Thank you.
Hello, my name is Wong. I'll be talking about discussion, power and temperature. So the discussion asked for me to create a chart of temperature against power. What can I say about the chart, the graph? So first, we can see on pin type, temperature start on 10.5, but as the power goes up, the temperature decreases from 7.5 until for 10 volt is 7.2. Starting from 15 to 50, the temperature difference has increased, but the gradient is way lower than the fin type. For the fin type, as the power goes up, the temperature goes up. For the highest peak is 53.5. Meanwhile, for the pin type, the highest is 26.7. This shows that the pin type actually performs better convection than the fin type surface. So the next thing is we have to calculate and estimate the gradient for each graph. From the graph, what can you predict about the gradient for other surface? So I'm gonna compare 2 of the gradient. So first we use pin type. We are going to pick 30 watts and 5 volts, which is 12.4 minus 7.7 divide by 30 minus 5. So the gradient is 0.188. As for the gradient for fin type, we also use 30 watts and 5 volts. So the gradient we get is 1.036. So based on the calculated gradient, the prediction for pin type surface, when the power goes higher, the temperature difference will not be as high due to the gradient is only having a value of 0.188. So for the fin type, as the power goes up, the temperature difference will increase a lot due to the gradient has a value of 1.036 and it's greater than the pin type. So the pin type surface will not increase as much compared to the fin type. So one of the main reasons is the pin type distribute the heat and perform better convection compared to the fin type surface.
Hello, my name is Muhammad FARIS bin AZHAR. I will give 2 suggestions on precaution steps that you can take to minimize the time to stabilize the surface temperature. For number 1, keep the gradient temperature as low while the experiment is running. The environment temperature might differ the data of the experiment. For number 2, air circulation must be smooth, so it is suggested to the experiment must perform in a ventilated place. And for the conclusions, number 1, The higher the power, the higher the difference of the temperature. Number 2, the pin type surface has a better convection heat transfer compared to the funnel type and flat surface. For number 3, convection is well performed in well circulated system. For number 4, the more the heat travel, the lower the temperature becomes. For number 5, students can understand the principle of convection and understand the purpose of the experiment. Thank you, that's all.